Alright, this lesson is on logarithmic functions. Logarithmic functions are inverses of exponential functions. So we can interchange the two formats. So on the left, we've got the exponential form, an exponential function. On the right side, we've got a logarithmic function. The way that we interchange the two, if you start off in exponential form, you take the base of the exponent, and it's going to be the base except for of the logarithm. So a is the base of the exponent on the left side, a will be the base of the logarithm on the right side, and then we just flip the x and the y. Alright, so the y was on the same side as the a, now it's on the other side of the equation. The x was on the opposite side of the a, now it's on the same side of the a. So if x equals a to the y power, that's the same thing as writing y equals log base a of x. So we need to understand some of the log properties. Whenever you have log base b of m times n, to expand that, that's just the same thing as writing log base b of m plus log base b of n. And as you probably expected, whenever you're taking the log base b of the quotient of two numbers, that's the same thing as expanding it and writing it as log base b of m minus log base b of n. And then whenever you have log base b of m to the p power, that's the same thing as bringing that exponent down in front of the logarithm. And if log base b of m equals log base b of n, that means that m and n are equal. Alright, so first thing we want to do is take this logarithm and write it in exponential form. So that's the way that we change from exponential to logarithmic and vice versa. So we start with the base. The base of the logarithm is 6, so that's going to be the base of our exponent. So we write the 6, and then we're going to interchange the 36 and the 2. So 2 will become the exponent for the 6, and 36 will go to the right side of the equation. So 6 to the second power equals 36. Make sure that you write your exponent on the left side of the equation just so that it matches up with the answers in Go Formative. Alright, now we want to do the opposite. Write this in logarithmic form. So we can go ahead and write log base 81, since 81 is the base of our exponent. So it's going to be the base of the exponent will be the base of the logarithm. So log base 81, and we're just going to flip the two numbers. 1/9 will go to the left side now, and the negative 1/2 will go to the right side of the equation. Alright, so we've got 81 to the negative 1 power. Negative 1/2 power equals 1/9, so 81 will be the base of the logarithm. And then flip the 1/9 and the negative 1/2. So 1/9 goes to the left side of the equation, and the negative 1/2 goes to the right side. Again, write the logarithm on the left side. Alright, we want to expand this logarithm. We've got two things. We've got up under the radical sign, we've got x times y under the radical sign. So we can rewrite that as the quantity x times y to the 1/3 power. So that's the first thing that we want to do. And we can expand, we have z times that radical, so we can expand that as log base 3 of z plus log base 3 of the cube root of xy. And then again, we can rewrite the cube root of xy as parenthesis xy to the 1/3 power, and then we can just bring that exponent down in front of that logarithm, and then we just want to write that whole logarithm over 3. and we have the log of the product of two factors. So we can expand that log base 3 of xy to log base 3 of x plus log base 3 of y. And both of them have a 1/3 in the front. We could just rewrite that as log. We want to put the logs in alphabetical order. So you want to put the x log first, then the y, then the z. So you have log base 3 of x over 3, log base 3 of y over 3, plus log base 3 of z. Next example, we want to expand this also. So we have, we're taking the log of a quotient, so we can expand that by subtracting the numerator and denominator. Log base 6 of u cubed minus log base 6 of v squared, and then just bring both of those exponents down in front of both logarithms. And that's our answer. Again, put them in alphabetical order. So the log of u is going to come before the log of v. Now we want to condense this logarithm. So first thing we're going to do is bring all of those numbers in front of the logarithms up to the exponent of what we're taking the logarithm of. So that would be log base 7 of x to the 30 power of 30 minus log base 7 of y to the 5th power minus log base 7 of z to the 5th power. And then now whenever you're subtracting, when you condense it, that becomes the quotient of whatever's on the left over whatever's on the right. So when I condense those first two terms, I get log base 7 of x to the 30 over y to the 5th. And then whenever I divide x to the 30 over y to the 5th by z to the 5th, that's the same thing as multiplying it by 1 over z to the 5th. So that will give us log base 7 of x to the 30th over y to the 5th, z to the 5th. And again, put everything in alphabetical order. Alright, we want to condense this one also by, we want to start by bringing the exponents up to what we're taking the logs of. So log base 3 of 11 to the 5th plus log base 3 of 2 to the 5th plus log base 3 of 5 to the 20th power. And whenever you're adding logs, you just want to, that's the same thing as multiplying them whenever you condense the logarithm. So we're going to have log base 3 of 11 to the 5th times 2 to the 5th times 5 to the 20th. And whenever you're writing these out, you want to put a multiplication sign in between. In Go Formative, I believe it's an X. Yeah, I believe in Go Formative it's an X. Put the factors in numerical order, so the smallest base to the biggest base. Alright, so for these we're just going to use the calculator. For these you're going to press on a TI 83 or above, you're going to press the math button. Well, for the first log you don't have to, because the first two have a, there's no base written for the logarithm. The base is understood to be 10, a common log, log base 10. So that's the log that's already on the front of your calculator. So you just have to type in log of 4.1. Rounded to the 3 decimal places would be 0.613. Same thing for the second one. Whenever you type in log of 22, you get 1.342. And then now for, if you have a different base for your logarithm other than 10, you have to press the math button and then use the log for, you want to click on the option that gives you the ability to choose the base of the logarithm. So you want to, I think you have to press the 3 first, and then math, and then that log with a box for the base, and then it should show up as log base 3, and then you want to type in 28 and it'll give you 3.003. And then for the same thing for log base 5 of 37, I think you have to type the 5 first, press the math button, go to that log with the indicated the box for the base, and hit enter, then type in 37, hit enter, and you get 2.244. Alright, now to evaluate a logarithm, you want to change it to exponential form. So we're going to set this whole thing equal to y. You want to find out what this what the value of this logarithm is. So we're going to change this to exponential form. To change this to exponential form, we're going to take the base of the logarithm 6, raise it to the y power, and set that equal to negative 216. And then I'm going to factor 216 to see what that is as an exponent, and that's 6 to the third power. So 6 to the y equals negative 6 to the third. Alright, and the base on the left is positive, base on the right is negative. Base on the left is positive, the base on the right is negative. So that tells us that there is no solution. Alright, because we do not have the same bases. Next, we've got log base 7 of 343, so we're going to set that equal to y. Rewrite it in exponential form. When we write that in the exponential form, we'll have 7 to the y power equals 343. And 343 is just 7 to the third power. So I have 7 to the y equals 7 to the third power. The bases are the same, so you can set the exponents equal to each other. You get y equals 3.